Welcome to Fragile Diamond Service. This is the first in a series of brief videos covering Fragile's unique and multifaceted approach to process cooling. Originally displayed at NPE 2018 in Orlando, the entire interactive presentation is available to all of you for downloading. We urge you to review this valuable tool and use it for brief customer presentations to demonstrate how Fragile takes a leading scientific approach to process cooling. It's set up so that you can easily flip to the sections which contain information most relevant to a specific customer or application. This first segment covers determination of the thermal load for each application. Defining thermal load is always the first step in analyzing heat transfer requirements. This section demonstrates how Fragile takes these analyses to the highest possible level. We will review accepted conventional methods and their typical negative results, and show how Fragile not only eliminates those results, but also optimizes operating efficiencies. For many years, determining the cooling load involved asking three simple questions. What resin or resins are being processed? What's the expected optimum processing rate? And finally, what's the temperature of the cooling water supplied to process? As time went on, manufacturers and their representatives learned to ask two more questions. If they remembered, what's the actual operating kW of the hot runner system, if applicable? And if TCUs are being used, what's the pump horsepower of each zone? Both of these additional factors contribute to the heat loads. But are all these questions enough? The answer, quite simply, is no. This conventional, non-scientific approach quite often leads to standard catalog chiller selections. The numbers indicate you need 10 tons. So here's a standard 10-ton chiller for you, Mr. Customer. And those catalog chillers do not have all-encompassing operating intelligence, which leads to extensive and ineffective troubleshooting. The results from this conventional approach often lead to oversized chillers, which in turn leads to inefficient cooling and increased energy costs, not to mention equipment costs. These standard selections lead to part quality, warping, and scrap problems, as well as poor thermal dimensioning of the product. And from an operational point of view, a bottleneck in production is often caused by these negative factors. Now let's talk about what we are calling the TENS. In our neck of the woods, heat exchangers are typically selected based on the TENS shown here. 10-degree rise in coolant temperature through the exchanger, a mold for example. 10 psi pressure drop through the heat exchanger. And 10-degree approach, which is the difference between the coolant temperature and the temperature of what is being cooled. In simple terms, a conventional catalog chiller is designed for these TENS. For example, a conventional 10-ton chiller supplies 50-degree water to a mold, and the mechanical design is based on the assumption that the return water will be 60 degrees and the pressure drop will be 10 psi. Those are the conventional factors, but such designs and selections frequently result in ineffective and oftentimes catastrophic results. These TENS do not apply when talking about the plastics industry. Molds, chill rolls, and even extrusion tanks will not operate efficiently based on the TENS. You may ask, but of course we ask the same basic questions. They determine what the thermal load is at its most basic level. Now let's look at how Fragile's diamond service shines above all others. We look at how the thermal loads are distributed, for example, between mold halves, multiple series chill rolls, multiple series extrusion tanks, etc. We analyze temperature profiles for multi-zone applications. And we strive toward achieving optimum flow characteristics by analyzing cooling channel sizes, circuiting, pressure drop, and so on. Diamond service results are numerous. Optimum chiller selections resulting in maximum operational efficiencies, increased part quality and consistency, reduced rejects, and, for example, a reduction of molding cycle times typically as high as 20%. We trust that this brief presentation will provide you with the ammunition to clearly demonstrate how Fragile takes thermal load analysis to the highest scientific level. We recommend that you use this video while viewing the presentation to practice the talking points that apply to each screen. Be on the lookout for upcoming additional videos covering the other diamond service segments: temperature, flow, and now closing the loop with energy. Thanks for your attention.